talk about that. So good morning, everybody. I'm glad that you guys are here. So yes, there will be homework. Sorry, not sorry. No, it's just going to be due next class, like always. It's not going to be due over spring break. So our next class is the Monday after spring break, which is whoop, whoop, whoop. When is that? That is the 12th. So it's going to be due the 12th. So my advice is if you wait to do it, you won't do it. So I would do it as soon as possible. I understand life happens and people are going to be on vacations and stuff. So I'll send out a reminder email next Friday, just being like, hey, don't forget to do your homework, okay? So I'll do that for you guys as well. So yeah, it's not going to be do it over spring break. I'm evil, but I'm not that evil, right? So I draw the line at being evil and being a math teacher. I'm not actually evil outside of that, okay? With that said, I just also want to double check in. We have a lot to do today, so I'm going to get going. Make sure if you guys need help that you're asking for help. I don't really have a lot of you guys asking for help, so it's really important that if you guys need help that you are asking for it. So it just worries me. I mean, it doesn't worry me. I mean, you guys could be doing totally fine, but just remember that if you guys need help, I am here. You're not in this alone, and you can come to my office hours. We can do homework together. We can go over examples in that we do in class. There's lots of things I can do to help, okay? So just make sure you guys are communicating and advocating for yourself because there's lots of ways I can help, okay? All right, so with that said, let's get into this. We are doing some review of trig identities. So the very first thing that I want to talk about is in the book. So whether you guys are looking at the book digitally through WebAssign or you have a physical copy, remember if you don't have a physical copy and you want a physical copy, they are available to check out through the library. Okay, so in the book, I would just reference you to page 348. Okay, because on that page, and I'm going to show you guys right now. So on that page, there is a lovely list of all these trig identities that we need to do. So I'm going to be going over these today, how to use them, why do we use them, and so on and so on. Okay. So and we're going to be exploring using them a lot more in this class. Okay. So trig identities, why do we have them? Why do we do them? Because as our algebra and math with trig functions get more and more complex, we are looking for tricks that will make problems easier, right? And that's what these trig identities are. They're really just tricks that make things easy, okay? So, and I'm just going to say this now, and I'm going to say this throughout the whole class, is that sine and cosine are the same thing. Anytime you're trying to solve a trig function, you want to get it in terms of either sine or cosine. So I really want to stress that. Okay, so first I want to talk about is reciprocal. Okay, so reciprocal just means flipped. Okay, so the idea that that sine of u equals 1 over cosecant of u. Okay, so cosecant, right? That just means cosecant of u equals 1 over sine of u. So you'll notice there is no cosecant on a calculator, okay? So you're not going to be able to do cosecant in your calculator. You're going to have to get it in terms of sine. And this is what I mean. Anytime you're doing trig problems algebraically, you want to get it into either terms of sine or cosine because ultimately sine and cosine are the same. Now, I don't know about you guys, but when I was in high school, I had a huge difficulties with between sine and cosecant because you would think the s would go with s, but it doesn't. It goes with cosecant. And then just like the same here, that cosine of u would be 1 over secant of u. And so I always had a really tough time with these because I would get them wrong. So again, remember cosine goes with secant, sine goes with cosecant. You would think cosine would go with cosecant, and you would think sine goes with secant. Okay, but the way I remember it is that the reciprocal, so they're flipped. So instead of s going with s, it's going to be s going with c. And that's just kind of a gimmicky way that helps me remember that sine goes with cosecant and cosine goes with secant. Okay, So those reciprocal identities. You need to know them because, again, cosecant and secant aren't in your calculator. Well, unless you have a TI like 89, then you can just type it in. But it just takes so much longer to type it in than it just to realize that it's just 1 over sine or 1 over cosine. Okay? The last one being cotangent of u, right? Which is just 1 over tangent, right? Or tangent of u. I feel like I wrote that wrong. Tangent of u equals 1 over cotangent of u, and cotangent of u equals 1 over tangent u. So the cotangent, I think it makes sense because it says cotangent, right? So it's 1 over tangent. The ones you have to look out for are sine and cosine, okay? Because again, the sine goes with the cosecant, not the secant. Okay. Now, we're not graphing cosecant and secant, so really you just have to remember these identities and know that when we're solving things, you want to get in terms of sine and cosine. Okay, I feel like I'm repeating myself, and that's good. We want to repeat ourselves. Now, some side ones that I want to add in here while we're here. Also remember, because this really isn't, well, yeah. So that was a reciprocal identities. Sorry, I was going to add something, but I guess it's not. So those are the quotient identities. I'm sorry, the reciprocal. Quotient, right? If you remember, quotient means division. Oh, this is an identity. Whatever. Okay, so quotient, the quotient rules, there's only one really, and that's tangent of theta equals sine of theta over cosine of theta. Okay. So you just need to know that. And then just remember cotangent is 1 over that. So it just flips. Right? So remember, a reciprocal is when we flip. So cotangent is just going to be flipped. You need to know that. You should have those down. And then the Pythagorean identities. These are actually so big. They happen so much, and I can't stress how useful the Pythagorean identities are in calculus. Like, they are just so important in calculus, and that's the name of this class, right? Pre-calc. So knowing these is really important. Now, the first one's really easy, okay? And the first one, if you take a look at a unit circle, I should say what we're talking about. We're talking about Pythagorean identities. Okay, so if you have a unit circle and you have some point x, y on the unit circle with a radius r, then that means that your height is y and your width is x. Okay, which means, right, we know this to be as x squared plus y squared equals r squared, right, the equation for a circle. But we have to remember that in the unit circle, this is also sine theta, and this is cosine theta, where my reference angle is theta. Okay, and I know I'm kind of going a little fast, but this should all be review. Okay, so remember my y here, right? That can be written as sine theta, and my x here can be written as cosine, right? When I'm talking about circles. So that's where we get this trig identity, that is cosine squared theta plus sine squared theta equals r squared. Okay, and if it was a unit circle, right, this would be 1. Okay, so what's important here is, first, remember notation, right? When I say cosine squared, the reason why we do this, and I just maybe do a little aside here, when I say cosine squared theta, the reason we put the squared here is because we don't want to confuse the squared with being with the input, right? So just remember, this means cosine of theta and then parentheses squared. So we don't normally write it like this because there could be confusion that that squared is going with the theta, And that's why we write it like this. So if you see cosine squared theta, that really means this. And that means it for every trig function. So if I say sine squared theta, that's really sine of theta squared. Okay, so make sure you guys know that. Okay, so this right here is your bread and butter. That's easy to prove. So the other ones, I don't know if I'm going to have times for this. The other ones we can prove. So the other ones, right, is 1 plus tangent squared of theta equals secant squared of theta. And the other one is 1 plus cotangent squared theta equals cosecant squared theta. Now, you might be thinking like, how the heck am I going to memorize these? And the trick is, guys, that you don't have to memorize these last two, because if we turn these into terms of sine and cosine, you'll see it's the exact same thing as this, as in these two are not unique. Because remember, tangent, secant, and cosecant are actually just different. They are sine and cosine manipulated, okay, either using quotient or reciprocal. So which one, you guys pick in chat, 1 or 2. Which one am I going to prove, 1 or 2? Okay, 1. So the first thing I'm going to do is I'm going to get everything in terms of sine and cosine. So we're gonna be proving that this is the same. We're going to prove that this is the same as cosine squared plus sine squared equals r squared. Okay, so the first thing I'm going to do is I'm going to 1 plus. So I'm going to replace tangent with sine squared theta over cosine squared theta. And then secant is 1 over cosine squared theta. Okay, so I'm just going to stop there. Do you guys agree with this? So if tangent, right, if tangent equals sine over cosine, then tangent squared would be sine squared over cosine squared. And if secant equals 1 over cosine, then secant squared is 1 over cosine. And the next, and this is, I'm almost done with this proof. It's really easy, right? If I want it to look like this, I don't want cosine squared on the bottom. So what I'm going to do is I'm going to multiply both sides by cosine squared. So I'm just going to multiply both sides by cosine squared because there is no cosine squared on the bottom here. So what do I end up with? Cosine squared, right, times 1 is just cosine squared. The cosine squareds are going to cancel out here, so I get sine squared theta. And then the cosine squareds cancel out here, so I get 1. Okay, so there I'm done with my proof. Notice how this right here is the exact same thing as this. And I should change this. We should just change this to a 1. Okay, do you guys see that? That how this right here is the exact same thing as this. Heck, I'm going to go ahead and do the other one really quick because I'm just having so much fun. Right, so if we look at 1 plus cotangent squared of theta equals cosecant squared theta. So again, I'm just trying to prove you don't have to memorize these two. You can always get it in terms of sine and cosine. And that's the trick, right? So this would become 1 plus cotangent, so it's tangent flipped. So that would be cosine squared theta over sine squared theta. And then that will equal cosecant. Well, cosecant is 1 over sine squared. And as you can see, this is the exact same proof, but instead of multiplying by cosine, I'm going to multiply by sine squared. Okay, and you're going to end up with sine squared theta plus cosine squared theta equals 1, which is the exact same thing as this. So again, the Pythagorean identities are super important, but you just need to know the basic one. That's really easy to prove because these two aren't, gosh, I can't think of the word now. Independent. They're not independent. They're not unique. That's the word I'm looking for. They're not unique. Okay? They're just, oh my gosh, they're just I can't think of the right word, and I'm really embarrassed, and now I'm gonna cry a little bit on the inside. Okay, so Pythagorean identities, really important. Okay, the big takeaway you should see about Pythagorean identities, if you see a trig identity squared, a trig term squared, probably going to use this. Probably going to use Pythagorean. Okay, so if you see a trig term squared, you're probably going to use Pythagorean identity. Okay, and that's what's going on there. Do you guys have any questions so far? So again, big takeaways. You can always get things in terms of sine and cosine. And if you see something squared, you're probably going to use a Pythagorean identity. Okay, oh my gosh, we have so much to do today. We're gonna go. I get too excited and we talk too much. So I'm gonna do a bunch of examples of trig identities today to help you guys out. So the first one being, so if secant of u equals -3/2 and tangent of u is greater than 0, we're going to find all 6 trig identities, or trig functions. Okay. So what I would do with this is I would draw a triangle, because having the visual just makes so much sense. Now, if you do trig all the time, you can do this. You can do this just purely with what am I trying to say? Purely with your brain. But let's take a look at what this means. So if I have a right triangle with a reference angle, we have to remember secant is 1 over cosine. Right? So that would mean cosine, I'm going to make this theta because I'm so tired of u. Cosine of theta would just be this flipped. So it'd be -2/3. Okay. Does that make sense, guys? Right? So if secant is 1 over cosine, then cosine is just going to be that flipped. So let's take a look. Maybe it would have been better to take a look at a unit circle first. So that would mean, where's my triangle going to be? Well, I know my hypotenuse has to be positive. So I'm going to be going 2 to the left, and tangent is greater than 0. So that would mean, so if you take a look at tangent, right? So this is plus plus, this is negative plus, this is negative negative, this is positive negative. The only place where tangent can be positive is here and here. So when I go to draw my triangle needs to be left 2, radius of 3. So it's going to be in this third quadrant. Does that make sense, guys? So if I drew my triangle out, it's going to look like this. Are you guys? I'm trying to make this sense, right? So again, the first thing I did is I don't want this in terms of secant. I want it in terms of sine or cosine. So I flipped it, right? So I would just take cosine and then I flip it. So -2, 3. So then I know that I'm going left 2 and my radius is 3. But tangent is greater than 0. So I can't be in the second quadrant because tangent would be negative. But if tangent's in the third quadrant, it's going to be positive. So I know my triangle is in the third quadrant. Do you guys have any questions about that? Okay. So then to find the rest, I just need to find this missing side, right? So that missing side would be -2 quantity squared plus my missing side quantity squared equals 3 quantity squared. So my box will equal the square root of, now it's going to be negative, right? Do you guys see how it's going to be negative? Just want to make sure you guys know that. Okay. So it's going to be negative because it's in the third quadrant. So it's going to be 3 squared and then minus 2 squared because negative 2 squared is the same as 2 squared. Okay, I'll keep it in there so not to confuse people. So then 3 squared is 9, 2 squared is 4, 9 minus 4 is 5. So this is going to be the square root of 5. Okay, so then if cosine, so then sine of theta would equal, right? So this is negative. Do you guys see how that's negative? So it's super important you know what quadrant you're in, right? So this right here, this tells you what quadrant was, right? This tells you what quadrant you're in. Okay, that tells you what quadrant you're in. So that's negative. So sine of theta is going to be negative root 5 over 3. Tangent of theta is going to be a negative over a negative, so it's root 5 over 3. Right? And then I'm not going to keep going there. We can find cosecant and cotangent. Are you guys okay with how I did that? Right? So like we could easily find, okay, I'll do it. Cosecant of theta is just this flipped. So it would be negative 3 over root 5. Now, they might ask you to simplify the radical, in which case it would be negative 3 root 5 over 5. And then cotangent would be this flipped. So 3 over root 5, which again, they might ask you to change that to 3 root 5 over 5. Okay, so any questions here? Sorry, I know I'm going a little fast. So how did we start, right? We started by changing it into either sine or cosine. We take a look at a unit circle. So we know I'm going left 2, right? The hypotenuse is never going to be negative, right? The hypotenuse is not going to be negative. It doesn't make sense to have an inverted circle. So we're going to go left 2. I know tangent has to be greater than 0, so it's got to be in the third quadrant, right? So I couldn't have used this one. Okay, so if it's in the third quadrant, I know my x value is negative. I know my y value is negative. We had to solve for the y value. Okay, so I'm going to hit pause for a second. Are you guys doing okay? Okay. All right. So that's one thing you can do with trig identities. The next thing you can do with trig identities is simplifying. Okay, so simplifying trig. So let's say I have sine of x times cosine squared x minus sine of x. Okay, so first trick, factoring. Okay, this is our first trick, factoring. If you have this exact same trig piece, so this has 2 terms, right? And if each term has the same thing, then you can factor that out. So what to do? I factored sine x. Okay. So there's an example of factoring. Now you're like, crap, that's not simplifying. You're right. Factoring in of itself is not simplifying. Okay. But what this did by factoring is it gave us this gem right here. Okay. So factoring usually is a way to change the way things look, and it reveals things. So in this case, remember I said if you have a trig term squared, you should always be thinking of Pythagorean theorem. So let's see if we can't get cosine of x minus 1. So we would get, so if I solve for this, right, cosine of x minus 1, so I would subtract 1 from both sides, and then I'd subtract sine squared from both sides. I would get cosine squared of theta minus 1 equals negative sine squared theta. Okay, so check this out. This, which we have right here, equals negative sine squared. So I'm going to pause just for a second. Does this make sense, right? So I see I have a squared term, so I'm going to use the Pythagorean theorem. So it says cosine squared x minus 1. I get cosine x minus 1, and I see what it equals. So this equals negative sine squared of theta. Okay. So then what I can do is I can bring this all together. So sine of x times negative sine squared of x, right? So we did a substitution using Pythagorean theorem, right? So again, if you ever see something squared, it's most likely going to be that. And then to simplify this, it is now negative sine cubed of x. And that is simplified. This up here is the same as negative sine cubed of x. That's simplifying, right? You took something that was multi-step, and now it is basic step. Okay, so this was an example of factoring something can reveal something that you can do, right? So we started by factoring. It revealed, oh, look, I have this Pythagorean theorem piece here, which allows me to substitute and simplify. Notice how I took something that has sine and cosine in it, and I got it just to sine. And I want to emphasize that those are big ideas, right? Can you get it to either all cosine or all sine? And in this one, it made sense to go to all sine. And then we can get it really nice and easy. And it's not complex. Like graphing this is a lot easier than graphing this and getting solutions, right? Solutions for this, really easy. Solutions for this, a little bit more complicated. So this is definitely simplified. Do you guys have any questions, comments, or concerns? Remember, if you guys are like, Kraft, I'm writing this all down. Cool. Great. You can also use your mic to ask questions because you can take notes and ask questions at the same time. Novel idea. Okay. All right. So no one's saying anything. So, and it shouldn't take that long to get down these notes. So you guys doing okay? Sorry, I'm not looking at the people who, there we go. Oh, nice hat. I like your hat, by the way. All right. So doing good. All right. Let's keep going. Because we got more stuff we need to do. All right. So what else can we do with this? So there's so much we can do. Okay. So the first one, okay, is we're gonna have secant squared theta minus 1. Okay, so we're going to factor this. Okay, so more examples of factoring. Okay, so now you might be like, what? How the heck do we factor this, right? Like, so a lot of people are going to look at this and they're going to be like, Kreft, I don't know how to factor this because this term, right, do we factor out a 1? Right? Because they don't have the same thing in each. But the trick here is don't think of it as what they have in common. Think of this as x squared minus y squared, or that is the difference of squares. Okay, the difference of squares. That's a C. right? So the difference of squares. So in a difference of squares, right, then all that means is you're going to have x just a second. X, oh yeah, x and x minus a. Right? So that a term goes away. That's a difference of squares, right? So this equals x squared minus a squared. Okay, so that's a difference of squares. And hopefully at some point in your life you learn this, because I don't have a lot of time. So what would our answer then here? Our answer here would be secant of theta minus 1, secant of theta plus 1. Okay, so there's just, it's a trick. It's called difference of squares, right? Okay, so I'm just throwing out tricks. Not that kind of trick though. That's dirty. Get your mind out of the gutter. Okay, so I'm just doing some tricks and just showing you guys. You guys want to put these into your box and do that. I don't think you guys got that joke, but that was okay. Maybe a little too inappropriate. So let's say the next one is 4 tangent squared theta plus tangent of theta minus 3. Okay, so then when you see this, what you should see is this. This is just a quadratic. Okay, if you don't like seeing tangent, so what you can do is you can just say, hey, tangent of theta equals x. So if you make tangent of theta equals x, you can also look at it as this. And can you guys factor 4x squared plus x minus 3? Of course you can. Now, I'm going to do this using a box. So if you guys don't like using the box method, that's cool. I'm just going to do it. Tricks are for kids. Well, I am pretty evil. Okay, so how is this going to work? Do you guys remember doing the box stuff? Okay, if you didn't use the box, that's cool, whatever. So it's going to be 4 tangent squared theta, and then down here is negative 3, right? So you have your squared term, you have your constant term. You might have learned how to do an x. So you multiply these two, right? Negative 3 times 4 is negative 12 tangent squared theta. And then the linear term, right, is tangent theta. So you have your product and your sum. So do you guys remember doing this? Right? We're looking for two numbers that multiply to get negative 12. Guys, this is just completing the square, right? Like, not completing the square, but this is just factoring, right? A trinomial. So two numbers that multiply the negative 12 but add to 1. So that means one's negative, one's positive. So what do we got? 12 and 1. We got 6 and 2 and 4 and 3. Okay, so these are all numbers that multiply. Now notice one of them's got to be negative, right? Okay, so how do you know which one's negative? Well, they're going to add to a positive number. And the trick here is whatever sign the adding is to, that's your bigger number. The bigger number has to be positive. So that means all these smaller numbers have to be negative. So let's see what they add to. So 12 plus negative 1 is 11. 6 plus negative 2 is 4. 4 plus negative 3 is 1. Winner, winner. Right? So 4 times negative 3 is negative 12. And 4 plus negative 3 is 1. So I'm going to have 4 tangent of theta and negative 3 tangent of theta. And again, if you guys don't like the tangent being there, you could just substitute out tangent for x. Just remember to go back and replace it at the end. So when I go to plug these in, it doesn't matter where I plug them in. And then negative 3 tangent of theta. Right? Do you guys remember doing this? Can you guys just give me Like you guys did this. You factored, because I teach this in Algebra 1. So you guys did this at some point in your life. Okay. So I'm going to take a look at here. What can I factor out? I can't, 4 and 3 don't have anything in common, but I can factor out a tangent theta. So what times tangent theta gives me 4 tangent squared theta? Well, that's going to be 4 tangent theta, right? So you guys see how I'm just working backwards to find the area of the small box? Then what times tangent gives me negative 3 tangent? What about negative 3? And then what times 4 tangent gives me 4 tangent? Just 1. And then double check. 1 times 3 is negative 3. So this factored is 4 tangent theta minus 3 and tangent theta plus 1. And I apologize, guys, that I'm going quickly, but I have 2 more examples I want to do with you today. Okay, so again, this so much didn't use trig identities, did it? So in this example, we didn't really use trig identities, but it's just like, hey, that algebra that you did with just quadratics, you can do it with trig, right? That's what this example is about, right? So all of that stuff you did with quadratics, it shows up in trig. And you know what? Trig turns out to be quadratics more often than not. Okay, so how are we feeling? Does anybody have any questions? I got 2 more examples and I got 12 minutes. Oh, I got 13 minutes actually. What do you guys think? Do you guys remember this? Hey, and remember, if you guys are like, Kreft, I don't remember doing this ever. Come to my office hours. We can do this and make you feel so confident. You're going to feel so good. It's going to be like doing push-ups and then like waking up the next day and your arms are bigger than your head, right? You guys don't have the same dreams as I do. That's okay. All right, so no one's saying anything. It's got me a tad worried. Okay, a tad worried. Are we doing okay, guys? You guys, we can factor? If you guys don't say anything, where did I get the negative 12? To get the product, you multiply the constant times the squared term. So I did negative 3 times 4 tangent squared. That's how I got the negative 12. So, like that. And if you guys want me to derive this process for you, I totally can. So like if you don't remember where this process comes from, I can show you that. I just don't have time today. Or if you want to stay after class, I can prove this to you and show you why it's true, okay? I don't have a lot of time and I have to assume you guys have some things. And so if you need help with that, please let me know. I'll help you guys out. Okay, so example 4. So now let's take a look at another one. Cosecant squared of x minus cotangent x minus 3. Okay, now we want to factor this. In chat, can someone tell me what's holding this back? Why can't I factor this right now? Yeah, the cosecant and the cotangent, right? These aren't the same trig function. Okay, to factor, right? Look at this one. To factor, do you guys see how this was tangent for both of them? But this one's cosecant and this is cotangent. So before we have to go, we have to get the same trig function. Okay, so we got to get the same trig function. So what did I tell you guys earlier? What should I be looking at? What's going to help me out here? How can I got to get one of these to be the other one, right? Which one should I look at? Did you guys pay attention? Which one should I be focusing on? Should I try to change this one with the squared in it? Or should I try to be this one without the square in it? The squared one, yeah. So we're going to have to use a Pythagorean identity. Right? So we're going to use a Pythagorean identity. So I'm not gonna lie, I don't have this one memorized. So how I would solve this is really different. I would get everything in terms of sine and cosine and then factor, but this way is shorter. I'm just gonna look it up. Oh, look at here. Cosecant squared of x equals 1 plus cotangent squared of x. All right. So anywhere I see a cosecant, I can replace it with that. So what do we get? We get, are you guys ready? My next line here is going to be 1 plus cotangent squared x minus cotangent x minus 3. So I have successfully replaced cosecant with cotangent, but now I want to combine the 1 and the negative 3, right? So I'm going to rewrite this as cotangent squared x minus cotangent x, and then negative 1 and positive 3 is negative 2. Okay, so just really quick, I'm going to do the factoring thing again. So if you guys were stuck on the first factoring, I'm going to do this one more time. So it's a trinomial that I'm factoring. So I know I'm going to have a 2 by 2. The squared term goes first. The constant term goes down in the bottom right. Okay, so squared term in the upper left, constant down here. To get my product, I'm going to multiply, right? So think about that. To get my product means multiplication. I'm going to multiply, right, my constant and my squared term. So I'm going to get negative 2 cotangent squared of x. And then my sum is my linear term, or my middle term. So I got to think here. Numbers that multiply to get 2. Well, luckily for us, 2 is prime. So it's got to be 2 and 1. Okay? But the tricky part here is they have to multiply to get negative 2. Uh-oh, is this going to get ugly? Did I do something wrong? Oh no, this works out fine. Guys, I'm so sorry. I just had a mental breakdown. Did you guys see that? Like, I literally was about to shut down and cry. All right, so if we multiply to get negative, one of these has to be negative, but the sum is negative, so the bigger one has to be negative. So we're going to have negative 2 cotangent of x, and we're going to have cotangent of x. So negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So let's see here, negative 2 cotangent of x and cotangent of x. Looks like I'm writing cut x. Okay, so again, I always start with the top row. I'm going to factor out the greatest common factor, which is going to be cotangent x, which means this is going to be cotangent x, which means this is going to be 1. This is going to be negative 2. So my answer is cotangent x plus 1 times cotangent x minus 2. All right, how are we doing there? I'm not going to lie, I have to go to the bathroom super bad, but I'm not going to because I'm here for you guys, right? Hashtag hold your pee for students. TMI? TMI. I'm just trying to get you guys excited about math, whether it be about Mr. Kraft has to use the bathroom really badly or the math is exciting. I don't care which one. It's a great story. You can be like, yeah, my teacher's weird. You don't even know. All right. How are we feeling? Are we feeling a little bit better about the factoring? Okay, we're going to end on the coolest problem of the day. You guys ready to be cool? No, I'm not. I'm trying to get warm. It's cold down here. All right, so let's do the last problem. It's the coolest problem. In Algebra 2, I know some of you guys, your Algebra 2 years was cut short, but in Algebra 2, there's a section on simplifying rational expressions. And like you start out with this like crazy ugly thing, and then it simplifies down to like 2. And you're like, what happened, right? I love that about math. I love simplifying. For me, it's like oddly satisfying. It's like picking your nose and getting a really long booger. It's that kind of satisfying. You're just like, did I just pull that out of my nose? Yeah. Was anybody looking? No. Perfect. Right? This is what happens when no one talks to me. Okay? All right. Let's take a look. So we're going to have here sine of t plus cosine of t times cotangent of t. So cosine of t, cotangent of t equals sine of t plus cosine of just there. So we're going to simplify. Okay. All right, it's good to know you guys are human. All right, here we go. So to do this, the first step is get everything in terms of sine or cosine. Okay, so the first one's already there, right? But the second one, right, it's cosine. Well, what's cotangent? Cotangent is cosine of theta over sine of theta. Right, so I just used a quotient identity there. Are you guys ready? This is so much fun. You guys ready? I truly think this is so cool. All right, so then what's cosine times cosine? Right, that is, oh, I switched to theta halfway through. I'm so sorry. It's cosine squared of t over sine of t. Okay, you guys get that? You guys with me? So now, do you guys see how this is a fraction and this one isn't? We're going to combine to get one term. So I want this to be that. So what I'm going to do is I'm going to do multiply it by sine of t over sine of t. Do you guys see how this is multiplying by 1? So what that gives me is it gives me sine squared t over sine of t plus, and then this stays the same. Okay, so I multiplied the left by sine of t over sine of t, and I get sine squared t over sine of t. And what does that give me? This gives me, well, I have common denominators now. So sine squared t plus cosine squared t over sine of t. What's sine squared of t plus cosine squared of t equal? Uno. You just, right? Uno. Okay, so next time you're playing Uno, instead of saying Uno, say sine squared plus cosine squared t. And then if someone's just like, you didn't say Uno, you can be like, oh, hell yeah, I did. And then you stick out your pinky, and you go. Okay. Maybe I play Uno with weird people. Is that what you guys are trying to say? Is like, Kraft, you need to check out your friends. You're a little weird. Okay, so this then becomes 1 over sine of t, which is just cosecant t. Now, that's so cool. I love that because this thing up here, sine of t plus cosine of t times cotangent of t, is the exact same thing as cosecant t. Like, that's pretty cool, guys. Like, that's pretty nifty, right? This and this are the same thing, right? So, a cooler way of thinking of it is cosecant is the same as sine of t plus cosine times cosine over sine. Or cosecant is the same as sine t plus cosine squared t over sine t. So it just goes to show you that these are really just sine and cosine. All right. Unfortunately, you guys do have a homework assignment. I'm so sorry. I mean, I'm sorry in the sense that, like, I know it's spring break, but I'm not sorry in the sense that, like, hey, this is pre-calc and we need to step up our game because you guys got to go to college and you guys want to do well in college, okay? So you do have a homework assignment. I do have office hours tomorrow morning, so if you guys want to stop by tomorrow morning and get help, I'm there. And then that way we can get our homework done before spring break. So I invite you guys tomorrow morning from 6:35 to 8:50, okay? Wake up early, have your whole spring break. That sounds like a great deal. All right, guys.